Today's live event was produced for the Connect Transform the Future program in collaboration with National Geographic Education and the Center for Science, made possible through the generous support of GE.
The world's demand for energy is constantly growing. To keep up with that rapid pace, energy producers are expanding their use of renewable energy. That means energy that comes from sources that are constantly replenished, like the sun and the wind. As the renewable energy industry grows, so do its career opportunities. Could one of them be the right fit for you and your future career? Well, that's hopefully what we're going to find out today. Hi, everybody, and welcome to Jason Live. I'm Patty Kim, and I'll be your host as we explore today's program, which is Careers in Renewable Energies. We have a very special guest today. This is Kathleen O'Brien. She is an electrical engineer, and she also manages GE's Power Systems Laboratory. We're going to find out what that means in just a minute, but first I just wanted to remind you that this program is live and interactive, so we're really looking forward to having you guys participate. Come on in, join us in this conversation, participate in the polls, throw us some questions via text or what have you. We'd be happy to hear from you. But first we're going to toss it back to Kathleen. So good of you to stop by. Thanks for doing this.
It's great to be here.
We are so excited to have you here. You know what, I'm going to get things kicked off right away with our first question. This comes to us via text, and I think this sort of frames the discussion perfectly. Ashley would like to know, what is your job, and how is it related to renewable and efficient energy?
Okay. So my job, at least until very recently, was to manage a group of engineers and scientists that are looking at technologies for the power grid. So all of those technologies that allow you to get electricity in your house, allow you to use anything basically that uses electricity. People in the group that I work with are inventing technologies in that area. Specifically with renewable energy, we're looking at what type of controls need to exist within a wind turbine or a wind plant or a solar plant to allow it to most effectively transfer power to the end customer, which could be you in your house or a factory or anyone else really that uses electricity.
Right, so it sounds so simple, but just to reiterate, you're talking about you've got a wind farm somewhere, and then you're trying to figure out how to get all that energy that it produces onto the bigger grid.
Yes.
And talk to me a little bit about the big electrical power grid that we kind of don't think about all that often. I mean, it's cool, isn't it?
It is cool, and yes,
it's big.
It's big. It's complex. Some people have described it as the most complex machine that exists today. Basically, what we have is a system that throughout, for example, North America, is connected electrically, or can be thought of as being connected electrically, almost from coast to coast. So really, you have one giant machine interacting with itself in order to deliver power to all the end customers that use electricity every day.
So your work really affects everybody's life, because everybody knows that they need electricity to plug in their computers, to make toast in the morning, and pick up the phone and make that call to mom, or
yes, absolutely. So anything that uses electricity is something that me and my group will work on and research and look into. Yeah.
Well, we're going to find out a little bit more about renewables. We're going to take another question. Talia would like to know, Kathleen, how does engineering fit into renewable energy in the real world?
Oh, okay. Well, how does engineering fit into renewable energy?
How do you apply that? What's the link?
Okay. So, I mean, there's really a lot of different ways you can answer that question. There is everything from how do you design, build, and manufacture a solar panel that can take sunlight and turn it into electricity, to, you know, how do you get a rotor on a large wind turbine to turn and bring energy out. So mechanical engineering, design of structures, electrical engineering, the part of bringing the energy out, civil engineering, how do you site a wind turbine, build a wind farm, material science, looking into what composite materials can you use to make some of these renewable generators. Really, every aspect of engineering can be thought of as fitting into renewables in one way or another.
Yeah, it sounds like there's dozens of jobs or specialties associated with something. So if you put a wind farm up, there's going to be all kinds of different skills that you need to get that operating going. We've got another text question for you now. This is from Terry. What is your favorite thing about your job?
That's a good question. I think right now my favorite thing, I guess I have two favorite things. Number one is I recently took a new position actually where I'm working with our GE business customers to sort of gear our technology development strategy in line with what we think is coming up in the industry and what the trends and needs will be in the future. So research is really interesting. And the other thing I really like about my job is that I happen to work in a research center that has scientists, engineers, mathematicians from all over the world and also every different technology space you could think of. So getting to work with such a diverse group of people is just, it's fascinating every day.
What are some of the maybe misconceptions you had going into this field? Things that you thought this would be like, and then you were surprised by.
Right. So I thought, I guess, like most people do, or like it's sometimes portrayed on television, that an engineer would be, or I would be if I was an engineer, working, alone in an office, doing a lot of math, which I am, but, just being very isolated and sort of a geeky stereotype that you see on TV. What I really do is much more interactive with other people, much more team-oriented. Although we use mathematics certainly and engineering scientific skills all the time, we're really talking with each other. We're coming up with solutions together. We're figuring out strategy, and it's not what you see on TV, certainly.
Sounds like a team effort all the time, and communication sounds like a really big part of that as well. Definitely. We are ready now for our poll. We hope you guys are. This is the first poll question of the program. Which of the following is not considered a renewable energy source? Is it A, wind, B, solar, C, natural gas, or D, geothermal energy? And you work with all of these categories of energy sources? Not to give away the answer just yet.
So my group doesn't specifically design these. We more deal with how you bring them onto the power grid. And because there are so many, they each have their own different characteristics, so to speak, then there are different methods that we use and different things that we have to be aware of in order to integrate each one of those into the power grid in a different way.
You know what? We're getting those results, and I've got a little producer talking to me in my ear, and it sounds like most of them are saying, or most of you rather, are saying natural gas. Is that right? Is that right, producer extraordinaire? That is correct. Okay, well, you guys, good job, because that is the correct answer. Natural gas, speaking of natural gas, it's huge these days.
Yes,
we
definitely.
Are producing more natural gas than ever before?
Yes, in this country.
In this country, okay. And this is a fossil fuel, as everybody knows. There is an end to the supply at some point. But that's interesting. Does that mean there's less and less room for renewables then in the big picture?
I think some people would say that, but I think you can also think of it as if you look at the generators that are used to take power from natural gas and turn it into electricity, those generally are able to ramp up and ramp down or change their power output very fast. So if we look at the fact that the sun doesn't always shine and the wind doesn't always blow, that means that we will need our non-renewable generators to be able to move up and down and deliver more or less power much more quickly than they do now. And natural gas has that capability. So in some ways you can say more natural gas enables more renewables on the
so they can work hand in hand.
They can work hand in hand.
Okay. Well, we're doing something special for you guys with this program. We are going to learn more about Kathleen in just a minute. But first, we also want to introduce you to all different types of other careers and job possibilities in the renewable energy field. And earlier this year, we got a chance to send a camera crew out to take a look at some working professionals, especially in the wind industry. So in this video, we're going to meet a man named Ray, and he's a GE wind turbine technician. Let's take a listen to what he does and why he loves it so much.
My first thought of them was, wow, that's huge. You know, it's a pretty magnificent, that's for sure. My name's Ray O'Brien. I'm a wind technician here at Stetson Mountain. I'm also the environmental health and safety coordinator here at the site. A lot of people joke around and say, you know, this is a view from my office, and you know, it is a view from my office. I spend a lot of my time up here. I make sure everybody is up to speed on safety. I do all the harness inspections, making sure the equipment is de-energized and there's nothing electrically or mechanically that can harm us as technicians while we're working on the equipment. And pretty much just make sure everything is going smooth on a day-to-day basis. Well, it's actually an amazing job as far as you're not coming up and doing one thing every day. You know, you're not coming up and just doing electrical work. There's numerous systems in the turbine as far as there's hydraulics, there's the mechanical system as far as the gearbox moving. You do have your AC electricity, you have your DC power, you have communication, whether it's Ethernet or fiber. Every day you're not working on the same piece of equipment over and over, so it's really good in that aspect. Really the toughest part is dealing with the extremes as far as really cold temperatures. Some days we come out and it's -10, -20, and depending on what the wind speeds are, you know, you're looking at wind chills that are -40, -50, sometimes worse than that. From day one, I've always been the type of guy who likes to tear things apart and put them back together. If something's broken, tear it apart, see how it works, put it back together, make it work again. That's really what drives me as a technician. I love tearing something apart, putting it back together. It's something that I love to do, and that's part of the job. Based on how the oil reserves and fossil fuels and all that's going right now, it's, you know, good to have wind power, and I just see this as being, you know, a start of something big. It seems like it's something that's going to be here for a long time, and I'm hoping it is.
Wow, check out the view from his office, huh? Isn't that cool? Oh my gosh. Some of those wind turbines are enormous, 20 stories high, some of them.
Yes.
And those blades can span the length of a football field in some cases. Amazing. Ray talked about how he got involved in the wind industry. I mean, he loved taking things apart. Was that your path as well? Can you say that that was the case for you?
No, you know, I think for me it was a little bit of a different path. Although I certainly took things apart and put them back together, as I think all children do, I was more interested in sort of the why do people decide to design and build a certain thing versus another thing, and how do we come together and you know, decide whether our mix is going to be renewables and coal, or is it going to be natural gas and, you know, something else. So
you were interested in sort of the larger picture
right.
of how we create power, or what
right.
sources of power we use?
Yeah, I would say that that's probably true.
Well, you know what? We've got a couple of girls standing by. They want to ask you a question. This is Hannah and Olivia with their question.
Hi, I'm Hannah. And I'm Olivia. We're from St. Philomena School in Peoria, Illinois, and we were wondering, why did you choose to be a power systems engineer?
Oh, okay, good question. So I didn't really, I think, choose it at any one point. It sort of, you know, unfolded in front of me as a roadmap. So I started in college by thinking I would maybe be an electrical engineer. I looked into that for a while. I seemed to be pretty good at it, so I started to work on creating some small circuits and electronics, and then got into some of the power space, and then was really still focused on, you know, individual pieces of equipment that bring power to the grid. And then I got interested in, you know, sort of, again, this bigger picture of how is it organized, why does it run this way, and getting, specifically in getting technologies out there that'll help bring renewable power to the grid. So it was a unfolding process.
It was a gradual kind of thing.
Yes.
You know, when you look at what you were like when you were, say, Hannah or Olivia's age, what were you interested in? How did you know you were even cut out for electrical engineering down the road in college?
So I don't think I knew that at that. I don't think I knew that. I think I was interested in a lot of stuff. I like to read. I like to figure out, you know, why people did things the way that they did.
Did you like maths and sciences and some of the things that you need?
I was good at it, but I wouldn't say it was my...
oh, there you are.
I wouldn't say it was my drive at a younger age, but it was certainly something that I, you know, was good at, and I sort of thought it would be a tool in my life, but I didn't really know that it would be my core focus.
That's great. Thank you so much. You know what? We've got another text question for you. You ready for this one? This is from Ashley. What fascinates you most about your job?
Oh, that's a good question. I think what fascinates me most is the fact that every time I think I fully understand something, I find out that I don't and that there's more for me to learn. So
it's always challenging, always
it's always
stimulating.
challenging, and there are always people there that are willing to push it to the next level and think about things in an entirely different way than were thought about before, and that just, it continues to be exciting every day because of that.
And on that note, what would you say is the quality that's really important to have in order to do the kind of work that you do? It's not just about the facts, right? And it's
Yeah, that's a good question. And it's definitely not just about the facts. That's a sort of something you have to know, but it's not the core. I think, maybe it's what the core thing you need. Maybe it's just, continuing to ask questions, not being satisfied with the answer. It's never good enough. I want to learn more, know more, do it in a better way all the time. I think that's really what I see, as sort of a fundamental characteristic. Yeah.
All right, another text question for you now. This one from Kim. What type of education did you receive to be able to do your job?
Okay, so I got a bachelor's degree in electrical engineering. I went off and I worked for a while in a company that builds submarines and decided I wanted to do more research. So I went back and eventually got a PhD also in electrical engineering, which allowed me to do more of the research focus.
And you got your PhD in Germany,
That's
no
right,
less.
yes.
In German, everybody. Did you speak German before you went abroad?
No, I didn't. I mean, I could say a few words, but I did
But
not.
now, Sie
Yeah.
sprechen Deutsch, right?
Yes. Yes, although I was much better when I was in school, but I can still manage my way around. Yeah.
Interesting. All right, well, we've got another question for you, and this time it's via video. Let's take a look.
My name is Matthew, and I'm from St. Philomena School in Peoria, Illinois, and I was wondering, what experiences did you have that contributed to you wanting to have this career?
Oh, okay. I think, as I said, it was sort of a winding road that got me here, but I think it's really the people that I've been exposed to and that I've seen the technology they're developing and, how they've been able to make an impact on the world with that technology that really got me there. It's really the community of people in this space that are so dedicated to making the most complex machine in the world run exactly, in the optimal way that it can.
Who are some of your heroes, your childhood heroes growing up?
Oh, childhood heroes. That's a tough one. I don't know.
Or heroes that you admire today. Are there any that sort of inspire you?
Oh man, that's a hard question. I guess really for me it's not maybe the big famous person that is out there talking to a lot of people, but the guys who sit in control rooms every day and make that power grid continue to work, and the complexities and the things that they know in their head that they can't write down on paper, the feeling they have for how that system is operating and how they're able to keep the lights on for all of us all day long is something we never think about, but I think it's a pretty heroic task to do.
The unsung heroes.
The unsung heroes, yes.
The anonymous ones, but the ones that are doing a very, very important job. We're going to go to our poll question right now. This is our second one of the program. This one is, when Kathleen was 12, she dreamt of pursuing this career when she grew up. I'm feeling a little Alex Trebek at the moment. Is it A, lawyer, B, historian, C, astronaut, or D, did Kathleen dream of being a nurse? Which one sounds the most likely? Which one do you think it is? She gave away a few hints, I think, because she talked about her childhood. Nurse, not sure. Astronaut, not sure if you gave any hints towards that. At the moment, astronaut's in the lead, but everything's getting a little vote right now, so it looks a little ambiguous. What is the correct answer, Kathleen?
I dreamt of being a historian.
A historian? Really?
Yeah, absolutely. I was
now,
fascinated.
How does that fit in? You're an electrical engineer,
Yes.
but you have this thing for history?
I do, and I still do. I did at the time, and I still do. And I think it's really, it seems very different, but it's really similar when you think about just, figuring out why and how we have a certain path to a certain goal. So I think a lot of figuring out how the past unfolded to get us to the present helps me to figure out, given the technology mix that we have today and the things that are going on in the world, what will the future look like and how can I develop technologies to get there. But
all right, and on that note, the big story, history, it's time to check out a couple of more career profiles. This time we're going to feature a couple of guys, Bill and Troy, and then you're going to meet Dave and Jacob. And what they do is manage and operate a wind park for a company in Maine called First Wind. We're going to hear about what they do, why they do it, how they do it, all that and more, so take a listen.
At Stetson site we have 55 1.5 GE SLE turbines, and they span over a ridge that is approximately 4.5 miles long. With 2 people keeping the place running, it takes a lot of man hours, and we're busy the whole time that we're here. My name is Troy Cameron, and my role here at First Wind is Assistant Operations Manager.
We work in an industry that's got electrical, it's got mechanical, it's got hydraulics. There's so many things that you can do in this industry. Tomorrow you'll be doing something different. My name is William Hare. I'm the Operation Manager for all the Maine sites.
As an Assistant Operations Manager, I oversee the day-to-day site operations. It is a lot of different things that we have to do. We have to be safety conscious, we have to be environmentalists, we have to be supervisors, accountants, good with equipment, we have to be mechanics, electricians. It is a lot of responsibility. There are a lot of things that can happen day to day.
You don't have to sit in an office every day. If you tomorrow want to go out and do some road work with Troy, I can go out and do some road work. I think that's why people really like the wind industry. Clean energy industry, I can only see it getting bigger.
The more renewable energy we have and the resources that we have, the better off the environment is going to be in the future.
My name is David Grant, and here at the Stetson Wind Farm, I'm a wind farm support specialist.
My name is Jacob Terrio, and I work at the Marcel Wind Farm as a wind farm support specialist. Being a wind farm support specialist, your responsibility is taking care of all the site vehicles, the maintenance records, the maintenance logs.
We do everything from snow plowing on the roads to repairing the roads to inspecting the high voltage facilities, cleaning the building, repairing the building, maintaining the building. We do maintenance on the site. We inspect the roads and maintain them. We do some work in the turbines, which is basically usually inspection work.
I would say my favorite thing to do is climbing turbines. That never gets old. And you walk in and you got your harness on, you got your hard hat on, and your safety glasses and your gloves, and then once you get up and you can look around and stand up, words can't describe.
When the wind farm is operating, the turbines produce electricity which is sent out to the substation. In the substation there's a variety of transformers, breakers and relays, which we monitor for any kind of damage, any kind of misoperations, to make sure they're maintained in an operating state. So at any point in time, if there's any problems with the lines, we can open and close those circuits to stop the flow of electricity in or out of the park. My favorite part about working here is that I actually get to spend approximately half my time doing office-type paperwork, but I also get to go outside and do about half my time in the outdoors, which I'm a big outdoorsman. I've always loved being outdoors and working outside.
Working on a wind farm, you can expect anything to happen. You gotta be up for anything. You come in the morning and you got a turbine down and you're needed to go climb. And so you could have a plan in your head and it could be changed really quick.
Now that's a job that'll keep you on your toes, huh?
Absolutely.
Okay, well we've got a ton more text questions for Kathleen. Let's take some of those now. Our first one, Kim, what type of education, actually we're gonna move ahead to Hannah. We already talked about Kim's question. If I want to develop renewable energy systems, should I do mechanical or electrical engineering?
Great question. So the answer is either. there are tons of mechanical engineers and tons of electrical engineers that work on renewable energy systems. So mechanical engineering is certainly more involved with wind because you do have these moving parts, and obviously that's very mechanically oriented. In solar, however, you know, especially PV solar, photovoltaic solar, which is these, you see the solar panels that we're seeing now that are outside. You might think of that as much more electrical because there aren't those mechanical moving parts, but even there we talk about things like, you know, how much wind can blow over it before they blow away, how do you deal with cleaning, how do you make the actual structure that those solar cells go into. Mechanical engineering and electrical engineering both play a huge role, and we can't do it certainly alone. We need both.
So both are important. Okay, well, great question and a great answer. Next text question from Jacob. Just like hydroelectric dams use magnetic forces, can we use the same principle for wind turbines? Is that's something that we can...
Hydroelectric, oh, maybe, are we talking about, I don't know exactly what the person asking the question means, but if we're saying that you know, we use rotation and then the, you know, the use of magnetic fields to induce currents on conductors, which is how we produce energy from sources like dams and wind turbines. It is, in fact, the same in both. And, you know, generally when a lot of the energy that, or electricity that we produce is produced by these rotating elements. So wind turbines, gas turbines, anything that creates power is oftentimes done that way through rotation and magnetic fields.
And on that note, can we store wind energy? Like say you start, you know, getting some energy going, can you actually hold on to it, or do you have to use it right away?
Generally you have to use it right away. The wind turbine, because it is spinning and it is obviously a pretty heavy thing, you can't maybe, you know, see from the pictures, but those are very, very heavy pieces of equipment. There is some energy in the rotation itself of the blades, and you can suck some of that energy out for a very brief period of time. But in general, we can't store that energy without some other device such as a battery.
A battery, okay. Our next text question now, thank you for that. This is from Joe. Do you imagine a world where renewable energy does not require grids and a giant infrastructure? It's a very thoughtful question.
Yes. So I think we're actually in that world right now. We don't actually need a huge grid infrastructure to bring renewable energy to people. And, you know, we see right now people who have solar panels on their houses, people who use, you know, wind turbines at farms to generate power.
And which one is more effective? The large scale kind of power plant thing where you're shipping all that power across the country, or is it sort of the more localized
It really depends on what you're looking to get out of it. So, you know, obviously it's much easier to build a giant wind farm than it is to build one wind turbine, because you have to build a road to get the thing in there. You have to, you know, have contractors who come and pour the foundations. Doing it in one place multiple times is much easier than doing it in one location and then doing it in another. But with solar, you know, for example, to put it on your roof and your neighbor's roof isn't that big of a difference in investment in getting it out there. So it really depends on what you want.
I see. Okay, well, we've got one more question. This one's from Grace. Let's take a look.
Hi, I'm Grace from St. Philomena School in Peoria, Illinois, and I was wondering, how will wind technology revolutionize how we will live in 10 years?
Right, so I think, you know, I don't know that wind technology will revolutionize how everyone lives in 10 years. I think the goal is to use more wind to get more power to the people so that we don't have to use as much of the other resources that we use today, like coal and you know, other things like that, to get power onto the grid. So hopefully, you know, it doesn't revolutionize our lives as much as it maybe teaches us to be more sustainable. It teaches us to be more energy efficient because we understand more about where our power is coming from. And, you know, certainly people will have more exposure, hopefully, to renewables.
Grace, thank you so much for that question, and thanks for that answer. Great answer. Okay, another question. This one's from Anupam. Is there any possibility of developing wind farms in a big populated city for energy generation?
Okay, so certainly that's possible. There are a couple reasons why that doesn't usually happen. Number one, You know, as you saw in some of the videos, the wind farms themselves can be very, very large and take a lot of land area. And you don't necessarily want to build buildings under that, although farms under that is certainly feasible and people do that today. So you don't necessarily want to take up that much space in a big city. The land is very expensive, but also big cities are not always in very windy places. So usually we want to put the wind farm where the wind is and the people aren't, and then move that power to the cities where the people are. Although certainly it is, you know, technically a viable thing that you could do.
I'm trying to imagine those wind turbines in the middle of Times Square.
Yes.
Or something like that.
They would certainly be a sight to see.
It was a sight to see. It would bring in the tourists. Good question. Very, very thoughtful question. Okay, we're going to go to the poll next. And here it is. In 2012, wind energy was the fastest growing source of power in the United States, accounting for blank percent of new generation capacity. Accounting for what percentage of new generation capacity? Is it A, 13%, B, 23%, C, 43%, or D, 73%? So before we go any further, you guys go ahead and start thinking about that, but new generation capacity, what does that mean in simple terms?
So basically every year, or almost every year I would assume, there is new generation placed on the power grid. So somebody builds a new coal plant, somebody builds a new nuclear reactor as an example, and certainly people are building wind and solar. And so the government will look at, in any one year, what was the mix of generation that was added to the power grid. So this is new stuff that wasn't here last year.
And just to put it in perspective, everybody, most of the energy that the U.S. produces is from fossil fuel plants based on coal or oil or gas. And renewables take up just a little sliver of what we produce in this country, but it's growing, right?
Right. I think now we're around 15% or so of our electricity every year is generated by renewables, most of that being electricity generated from hydro, which is, you know, big dams with water behind them.
But that's changing slowly, little by little.
But it's changing, and we are seeing a drastic growth in wind and growth in solar as well.
And you guys guessed it right, because the results are in, and most of you guessed 43% of new generation capacity. So that was the right answer. Good on you, as they say in some part of the world. Good on you. All right, we're going to head on to our next video. We've got another career profile for you, and this one's a fascinating one. This time we're traveling up to Boston, Massachusetts, where we're going to meet two guys, one named Matt, one named Pavan, and they work at First Wind's Distribution Asset Control Center. What is that? Well, we're about to find out. Let's take a look.
I'd say an exciting day in the DAC is what we like when there's a lot of wind. My name is Matt Forrest. I'm the DAC manager here, and DAC is Distributed Asset Control Center.
Distributed Asset Control Center, and that's the eyes and ears of the company. My name is Pavan Kumar Dhavaleshwar, and I work as a senior DAC operator, and what we do here is control and monitor wind farms all over US.
We run 16 wind turbine sites with 540 turbines, almost a gigawatt of electricity. In the control center here, we have our monitoring screens that the DAC operators use to maintain an overview of 540 individual generators. They're looking at turbines on a real-time basis. We can help predict what's going to happen with a turbine. The DAC operators make a lot of decisions to determine what is safe and what is not safe, and they coordinate with the site operations teams and the site turbine managers to make the right decisions on a daily basis.
We have control capability. We can shut down the whole fleet at one click. We can shut down the turbines.
We can operate the components in the substation and coordinate with the utilities and the balancing authorities that run the electrical grid to make sure our electricity goes out into the grid without a problem. It's a very complex job that requires your brain to be engaged full time. It's more than just turning a switch. It's asking yourself, what's going to happen if I turn the switch and I don't get the expected response? What are 3 or 4 likely scenarios that are going to could possibly happen besides the turbine starting up correctly, and what am I going to do for each one of those? Those kind of things have to be going through the operator's head every single time they start a piece of equipment.
It's pretty fast paced. We tend to feel overwhelmed and try to get panicked, but we have got used to it. And coming from the background I come from, I really enjoy that part rather than sitting idle. That really comes from good time management skills, multitasking, end of the day getting the things done in a safe, secure manner, and in a manner which really impacts the company in a positive way.
When I was in high school, I didn't know that I was going to end up doing anything with power generation. I kind of knew I liked physics and math, calculus, whatever it was, anything to do with engineering, mechanics. I like to build stuff. I like to do hands-on things.
And I really like this industry once I got into it, mainly because of the value it adds to the environment, it adds to the society. And once I started getting more involved into it, I really started liking it. It's because it's always changing. So there's something new you can add every day.
I think one of my favorite parts of that video is when he said, we used to get panicked, but not anymore. I'm so glad, Pavan, that you're not panicked anymore. We rely on you. Fascinating jobs.
Yes.
They look like they're very intense, and they demand a lot of different skills.
Yes, definitely. Yeah, I think there's a lot of, for anyone interested in a career in renewables, there's a lot of different things you can do and still contribute and bring more renewables onto the power grid.
Speaking of that, quick question before we dive into those text questions. Right now, most of the energy that we produce in this country comes from fossil fuels, but do you ever think there'll be a day when renewables are the major source of energy in this country, where things get flipped and we don't use as many fossil fuels?
I think that could happen. I think a lot of that depends on where we as a country and as a group of people that consume energy decide that we want the future to go. I think we certainly have the technology and the ability to create technology to enable that, should we as a society decide that that's where we want to go. And we see countries like Ireland and Denmark really getting close to that already today.
All right, well, related to that is our first text question of this segment. Which country has the best renewable energy jobs?
Great question, and I'm sure I'll offend every country that I don't mention. So I don't know a lot about other countries. Obviously, I work here, but I would say just from the industry and the excitement that if you're looking, at wind, something in Ireland, in Denmark would be a place that you could go to really see how it's done, well, and when there is a lot of renewables on the grid. If you look at Germany, they have a huge solar industry that they've really worked hard to build up. China is getting very, very heavy into solar and wind and renewables. And of course,
so there's
in
a lot
the US,
of options.
Oh yes,
yeah.
There
so
is,
it's
yes.
not just in the United States where you could take yourself professionally. You might end up in Europe.
Absolutely.
You might end up in Asia. Okay.
Yes.
On that note, we're going to take a question now. This one's from Jake Stecker. What do you think is the most efficient renewable energy source available as of right now?
The most efficient.
That's a really good question.
So efficiency would be measured in how much energy goes in versus how much energy comes out. So I'd have to do some calculations to figure that out. But I would assume that hydro would probably be highly efficient because it's been around a long time, so we've had a while to perfect it. Wind is getting more and more efficient, and when we say efficient, it can mean different things. It can mean how efficient is the conversion system between the wind and the grid. It can mean how much of the wind energy do we use to actually create power, which is called capacity factor. It can mean a number of different things, but
hydroelectric power is up there, and then
I would
possibly
suppose,
wind.
and then wind. Yeah.
Okay. Another text question for you now. This is one from Sasha. Which renewable energy is cleaner or the cleanest?
Again, a tough question. That depends on how you define clean. So, it takes a lot of different materials to manufacture a solar panel, for example. So some people might say, well, wind is cleaner than solar because it takes different materials and I don't like these versus the other. So really clean depends on your definition of what that means to you. And certainly, again, with hydro, right, we have a lot of big dams in this country that were built
A long
time ago. The power that you're using from those dams today is very clean because the dam was built many years ago. But if we were to try to build another one today,
you'd cause a lot of environmental havoc.
And how clean would that be relative to building a new wind turbine? And you have to factor in all sorts of other things, like how much energy does it take not only to pull the materials from the ground to build the steel, but then to move that steel from one place to another.
So there's lots of complicated little sort of equations to work out before you can get to the right answer. But thank you for that question. Another text question now. What is your biggest challenge in your job?
I guess it's probably making sure that it's hard to explain. Making sure that I first of all, stay current. Technology changes so quickly, and you can focus in one area for 5 minutes seemingly, and then you look over and somebody's done something amazingly new. That's tough, and I guess, keeping up with all the different, we have a lot, where I work, we have a research center in New York where I work, and we have others that are working in Shanghai, in Bangalore, in Munich, now in Brazil, and making sure that I get a chance to keep up with what's going on at every one of those sites can also be a challenge.
Wow, so you have to really stay current.
Absolutely.
No pun intended. Okay, everybody. Well, you know what? We have had so much fun with you, Kathleen. Thank you so much for joining us. We are out of time for today, but really appreciate you sharing your story with us and also for inspiring us. I am sure there are some people out there who are listening to you thinking, that sounds really cool, and I like those things too. I might go for that. Do you have any final thoughts or words of advice before we go?
I guess I would just say, everybody in renewables, whether you're an engineer, you're a communication person, you're a plant operator, we all have different paths and different careers and different things that excite us. So if you're interested in learning more about other people like me who are in renewables but maybe have a different path, you can go to, for example, the blog from where I work, which is called Edison's Desk, and you can read about a lot of different people who had a lot of different paths.
Edison's Desk. Okay, keep that in mind. And as well, it doesn't end here, guys. If you're interested in energy and you want to find out more, you know what you should try to do? Go to the Connect Transform the Future project on the National Geographic Education website. It's really cool because once you're on that, you'll find a ton of free online resources that are meant for you guys, people just like yourselves, kids from grades 4 right on up through 12, who are interested in thinking about energy and solutions to energy challenges that we face both today and in the future. Plus, there's a really cool online game called Planet Green, The Big Switch, so you might want to check that out as well. Well, for everybody here at Jason Live, and there's a big team here of invisible people out in the background, I want to say thank you so much. I'm Patty Kim, and hopefully we'll see you next time. Thanks so much, Kathleen.
Thank you.
Bye-bye.
Bye.